Oh, can I say twice? I'm light. Once is probably enough. All right. Are you doing okay? Or you need another minute or talk about it? You're good? Okay. So when I made a common denominator, I got cosine minus 1 plus x over x times quantity cosine of x minus 1, which is 0 over 0. It's a L'Hopital case, so it's appropriate to use derivatives. I take derivatives. I get negative sine x plus 1, which is good. Now I'm not getting a 0 case anymore. That means I'm done with my L'Hopital, but the bottom. The bottom comes out to be 0 and 0, right? All right, so that really means I need to figure out what kind of zeros to see if this is infinity or negative infinity, or I could just go with the WISI form of or undefined. Okay, so let's be man about it and talk about, is it infinity or negative infinity? If I'm approaching 0 from the positive side, what is this product approach? Small positive or small negative? Small negative. Okay, so this is 0 from the negative side, or small negative numbers. What about cosine of x minus 1? Cosine of x has to be less than 1, right? So this has to be small negative, all right? So I have small negative plus small negative, which makes, despite the fact I'm adding, it's still small negative, right? So what's 1 over small negative? Negative infinity. These are not particularly easy. They do take a lot of thought. Lots of places to make mistakes. Okay? All right. Going to the back side. The second indeterminate form of the day is infinity times 0. Always have in your mind that this is approaching infinity times approaching 0. Surely if it was actually 0, then it wouldn't be a non-issue. It's big versus small. Okay? It's still the same approach, though. You need to make rates to compare the rates, so make a ratio. Make a ratio and use L'Hopital. So towards that end, say you looked at this bad boy. If I look at this as t, this should be t, sorry. As t goes to 0, sine of t goes to 0 on the positive side. And log of t, here's the log graph. As t goes to 0, what are the y values approach? As t goes to 0, y goes to, or natural log goes to, negative infinity. So I have this fight between really small positives and really huge negatives, and the question is, well, who wins? And it's about their rates. So we need to make a ratio. Which one do you want to put in the denominators? Okay, let's go sine. At least that way we wouldn't have a negative exponent and a log. Let's do that. Log of t over cosecant of t. If we were to look at the indeterminate forms, you'll see that that's infinity and cosecant is infinity, so it is indeterminate in a L'Hopital sense this way. So now we can go about derivatives. What is the derivative of the numerator? 1 over t. And the derivative of the denominator? Negative cosecant t cotangent t. Before I'm really ready to evaluate, I think I would like to clean these up a little. So let's do cleanup step. By inverses, or by reciprocals rather, I could call this negative sine t tangent t in the numerator over t in the denominator as a cleanup step. Do you see what I did there? Okay. Then let's evaluate. As the top goes to 0, or sorry, as t goes to 0, the top goes to stink. And the bottom goes to poop. So what do we do? Another one. Okay? Double the fun for the same price. The denominator is, however, going to finally clean up to 1. So we're almost there. We can see the light at the end of the tunnel. The numerator, unfortunately, product rule, but we've done a million product rules. So first stays the same. Derivative of the second. Second stays the same. Derivative of the first. What are my top 4 trig values? What are those trig values? 0, 1, 0, negative 1 over 1, which is, all right. I should have made an example that didn't come out to be 0 because they really do exist, actually. All right, would you try that one, which is far easier, I think you'll find. And although it's tedious, it's not hard.
Wait, so do you have to show that these ones are indeterminate?
Before you go making it a ratio?
Yeah.
So that's a really good question. In L'Hopital, you broke math if you take a derivative and use L'Hopital when it wasn't indeterminate. And so in a L'Hopital case, it's crucial that you do show this before you take derivatives, because otherwise you just jack the problem completely. When we do this, if I went straight to this and I wrote this as this, I didn't actually take a huge mathematical leap there. I just did some algebra, which is totally allowed. So you don't necessarily have to if you wanted to rush into it. It's probably not bad math to do so. But if you don't, you didn't break any laws. How many L'Hopitals are you going to have to do? 2. That's the tedium. So what's your final answer? Shockingly, it's... So I guess the moral of that story is if you're not sure, put down 0. All right, on a test. That is pretty much the idea. It's with a little practice. Sometimes they can get a little hairy, but for the most part, they go okay with practice. All right, I would love to get 88 and 89 turned in. If you haven't turned in 88, what the heck? But if you have turned in 88, good job. You're my new favorite. I would like 88 and 89 turned in. So let me hand out some papers. I am trading trying to get caught up so that we get to what normal math classes do, which is I assign a homework, you do the homework, and you turn in the homework the next day. Wouldn't that be better? I'm not liking it.
Or be like extra behind it?
We're normal behind, but I'm not sure that it's good. I don't think it's good.
Oh, I think it's good, but like, are we more behind?
No, it's but I get a lot of people put my math to the back burner. Yeah, apparently you've got a bunch of senior college nonsense, whatever.
I just keep putting math back.
That's the spirit. Do your math first, then your future later.
Well, it's a lot.
Do it.
I'm going to be homeless, but at least I can do calculus.
Yeah, exactly. Calculus will keep you warm. Yes.
Yeah. Or like, write that down.
Oh, yeah.
Focus on your match. And your
I only want direct focus. No, that you can't ever say. Yeah, no, I've been trying to get caught up. I really have. I just no, I have. It's just the other classes are pressing stuff on me too.
David Schreider once said he wrote to hell is paid with good attention.
Wait, what?
So if we don't do our test,
Yeah.
I've checked so many times. So if we don't do our test.
It's not enough to intend to do your calculus, just like it's not enough to tell your bank or whatever, hey, I intend to pay you at some point. At some point, you actually have to do the calculus, not intend to do the calculus.
I'm doing it. I don't say that's just more practice. It doesn't matter what the policy needs to do, it's what it actually does.
That's right, exactly. Well said.
That's the context I was
I like it. 88 questions. Do you have any 88 questions? Or no, that's so played out, you turned that in a week ago, like you should
I
have.
turned
Pretty
it
much.
2 weeks ago.
I think yeah, it was long. Any 88 questions? Now that I've said you should have all turned it in, do you have the guts to say, yes, I have questions?
Or can you just give us the answers to the replacement problem?
Sure. Am I,
It's like 4 and it's a lot.
sure. 4, I have 32 pi over 15. I did that without a calculator so you can find the equivalent. You didn't have to, oh, I said no calculator, so that's what you should have, sorry. Let's see, what else is replacement? On 26, I guess you could say. Both of those cases should be 8 pi over 3. Regardless of whether you use x or y, the answer, the volume of the revolution should be. Are those the only ones I see?
Yeah, I think that's
Okay.
it.
All right, questions on 88? Just because you see my key, okay, this actually ticked me off. Is it time for a little gentle rebuke? Yes, it is. So, I posted my key, as always, I made a lot of mistakes. There was a problem on, I think it was set 86, where I did, what was it? Oh, it was that area, it was the maximum area by this rectangle, right? And we did all this calculus, and at the end, it was to find the slope, and you were supposed to do this, yeah? You with me? Now, on my key, actually it might have been the other way around, I think it was this way. On my key, I wrote -1, yeah? You with me? Now, do you agree that that's total, I think it was this. Do you agree that's total crap? Yes. And would you be surprised at how many people gave me that exact answer, -1 for that? They just mindlessly, oh, whatever, 2 minus 1 minus, must be that. Hey, here we go. That really demonstrates mindless copying of my key, if you said that also, okay? Because you are not even pausing to think. You're just mindlessly doing what you're told. Good little nonsense. Okay? So, 88. Questions on 88? None? All right then, 89. Here we go.
89.
89.
Number 11.
11 is a humdinger. I agree.
1 and 3.
1 and 3? Just 3. Sorry, I thought somebody said 1. Oh, 1. Okay, I thought I heard 1.
I have a really short question.
Sure. Sure.
5.
What are they? What is it?
Oh, for 7, I'm confused why it's not plus or minus 1, because -1 is in the...
You don't put it. Like I got that one.
Is NVT for derivatives or integrals?
But it said set.
Yeah, it is. So so I totally see the confusion here. If you look at the theorem itself, it says for the interval of inclusive A to B, but later on it says there is at least one number C between A and B, so it does not include the interval. And what is your other small question?
For 17, I might have done it wrong, but I thought that it was 2x to 2x times 1 plus natural log of 2x, and I did it over a lot, but I still got that, and it says in the answer it's 1 plus natural log of x.
So that happens a lot. If you had natural log of 2x, it's entirely possible they called it natural log of 2 plus natural log of x. Is that true?
But they just have 1.
What did you have? I'm sorry.
I had 4x to the 2x times 1 plus natural log of x.
And what did they have?
4x to the 2x times 1 plus natural log of x.
Oh yeah, those don't coincide. And these are exactly the same on here. And the 1 is the same. Yeah, something sneaky going on here. I'll look at that here too. I'll add that to the list. It's entirely, maybe there's a mistake in the key. I'll look at that. Okay, they asked about that in the last class too, and I didn't get it. So we'll get into that when we see it. 16, yes. Okay, 11. Part of the question might be how to do it, and part of the question might be what do I want to see, and part of the question might be the pre-calculus after. Is your question, how do I get from the differential equation to the amount equation? Do we want to go over that? What? Did I write in the box I want you to develop still?
It says start from the differential equation and find a particular solution. So I still do that to go from that all the way.
Maybe I didn't say it blunt enough, but I do want you to show it, okay? So the development of this, what I would like to see is that you can get from there to there. Partially, the reason I'm making you do all this is because it's going to help us later when we get to logistic, which is a little more complicated. Sorry. When you integrate, you get natural log of the absolute value of A equals KT plus C. On this case, hold off on the initial condition. You're going to try and get as gross of a constant of integration as you can, and it's not gross enough yet. So if we exponentiate, and then use exponential rules, I could call that e to the kt times e to the c, right? If I then dump the absolute value, I get plus or minus e to the c, e to the kt. Now this is a gross constant of integration. With a little bit of thought, you can make it a clean constant of integration. What would isolate that so I could sub for it is if this wasn't there. Well, I could make this not go away if I look at what happens at time equals 0. At time equals 0, I guess the amount would equal the initial amount, which in money terms is called the principal. All right? So if I put in that case, P for the amount, 0 for T, then that at the end of the day tells me that plus or minus e to the c, that whole thing is the same as the initial amount. And so in place of the initial amount from where I left off, in place of that plus or minus e to the c, I could take that grossness out and put in a big fat principal, or original amount. That then is a clean version of the exponential growth. So far, so good? The only other issue is that the interest rate. When they say the interest rate is 8%, I had a lot of questions. Does that mean I should use 1.08 or 0.808, and it is K is 8%. You might think, well, won't that cause the amount to get smaller? The answer is no. E to a positive exponent will get big. Okay? With that, then you should be able to solve the pre-calculus additional now. Does that make sense? Okay. Hang on 1 minute. While you do that, I'm going to look at you. 3 is the question: how much work do you want to show, or all A, B, and C? It's you have an even and odd function, and what's the combinations? Is your question how to show it, or what to do? What?
I just didn't know what to do since you weren't actually given any.
This is how I would approach it. If I know that F is odd and G is even, F odd implies that when I put in a negative, I get out the opposite result. And F even implies when I put in negative, I get out the same. So I will use those. FG, is it even or odd? In all cases, when you do an even or odd question, it amounts to what happens if you put in negative. Same result, opposite result, or totally different result. So if I do f of negative x over g of negative x, f of negative x is negative f of x. G of negative x is, actually I don't even know. What are f of g? I didn't write down what f of g is. They tell you that f is odd, g is even. F odd, g is even. That's what I screwed with myself. Okay, sorry. So, now I'm ready. If I put in a negative x, what happens? Because f is even, because f is odd, cock-a-doodle, then that would be the opposite of f. Because g is even, that would be the same as g. So overall, that's the opposite of f over g, and I conclude odd. Excuse me. Does that make sense? That's kind of the approach. Does that get you started? Shall I continue?
Yeah.
Okay, sure. One is the old trough problem. Where did you put your origin? Whoever asked this? Please tell me at the bottom.
No.
No? All right, where'd you put the origin? At the top?
Yeah.
Okay. So be it. So the water level is at -2, and the minimum is at -4. We?
Yeah.
Okie dokie. So on force, which is rho depth area, 9,800 for the water. The depth is about how far from the water surface it is, not how high from the container. So what's the depth if you put the axis there? -2 minus y, true. The area of each of these slices is a base of 2x and a height of dy, yeah? But I need to sub for x. Well, if you look at this, I think it was 4 tall and 8 across. If it's 8 across, then it's 4 halfway. Well, if it's up 4 over 4, what's the slope? 1. And the y-intercept is -4 if you put the bottom down there. So x is y plus 4. Oriented the way we have it. So that, with appropriate limits of integration, are the limits of integration from -4 to -2, or -4 to 0? -4 to just to -2, because you only have fluid in that region. We're just compounding where all the fluid has force. So that should always be about the fluid. That might have been the issue. the work then is rho distance volume. Again, in both cases, the limits of integration are just where's the fluid, because I don't care about pumping air out or force of the air. It's just about the fluid. The distance now. The distance is different. What's the distance? I'm pumping to the top of the container now. 0 minus y, exactly. The volume is still going to be length times width times length and width of the slices. So that idea of 2 and y plus 4 for the width and dy for the height, that's cool, but now I need to bring in this component, which I think is 3. So you need that in there. And then you should be rolling. Okay? All right, and 17. 17, we're having a different answer than the 2x. Oh. So I assume you took the log of both sides. Wait. Oh, yeah, this has got a little gotcha in there, huh? More than me. I like it. Yep, nope, I just broke math. That 2x is not the exponent to that 2f. So you cannot do what I just did.
Can't bring up y.
Can't do it.
You have to log y.
You could divide 2 over and bring it with a y. That's true. You can work out the right side, but you have to be doggone careful about it. That 2x cannot be brought down because it is not a factor or an exponent to the t. So I need to bring those separate. What can I do? Separate this. That? Log rows? Okay. So now I can bring down the 2x because it is an exponent for the x term, not the 2, but for the x term, yes. Now if I differentiate, then the, oops, this is a 2, sorry, that natural log 2 goes away, bye-bye, and it's just 2x, 1 over x, plus 2 natural log of x. That might be it then. Y is 2x to the 2x, 2 plus 2 log of x. Okay, now that answer is good, but that's not how they have their answer, if I'm not mistaken, right?
Oh, no, that's fine.
What is it? Yeah, if you take out a 2. Then, what now?
Oh, that's
4x.
4x.
So this, yeah, oh yeah, this is normal too. How do I multiply 2 times 2? Oh, that's right, it's 4. Good point. dy dx is 4. That goes to me overthinking. And then you're good. So there was more to that, you're right. I'm glad you asked. Good point. Okay, 16. 16 is a good question. So, x plus 2, is 16 still a question?
Yeah, I think so. I think so.
Oh.
I'm getting confused between the discs and the shells.
Did they asked you to use y, so you,
So it would be a shell.
it should be a shell, yes. Okay, if you have this region and a y slice revolved around the x-axis, it should be a shell. Okay. Anybody need me to continue with 16? Okay. Well, should we get started on 90 or just kick our feet up and take a break? Take a break. All right. So I can get 88 and 89 10 today. Yes. Turned in with pride and with quality work, not just some bunch of mumbo jumbo. Take pride in your work. If the job is big or small, do